Introduction to beats. A guitarist tuning a guitar often relies on listening for beats to help judge when two notes are of exactly the same frequency. When two notes of slightly different frequencies are played together, the sound gets louder and then quieter periodically. These variations in intensity are called beats. When the notes are of exactly the same frequencies, the beats are not heard. This tells the guitarist that the strings are tuned. In this lesson, you will be able to use decibel to define the levels of intensity of sound, calculate the level of intensity at a given distance from a point source, explain the formation of beats by the principle of superposition, and use the formula for beat frequency F equals F1 minus F2. Select 198 Hz and press play. Now click clear and select 200 Hz alone and press play. What do you observe about the sound of this note compared to the previous? Answer: the second note is of a slightly higher pitch than the first. Now select both 198 Hz and 200 Hz and press play. Listen carefully to the sound produced by these two slightly different notes. What do you hear? Answer: the sound gets louder and quieter periodically. Now select both 199 Hz and 200 Hz and press play. Compare the sound produced by these two notes with the two notes in the previous example. Answer: the sound gets louder and quieter periodically, this time at a slower rate. Now select both 200 Hz and 200 Hz and press play. Compare the sound produced by these two notes with the previous examples. Answer: the sound produced has constant intensity. These periodic variations in intensity are called beats. They are formed when two sounds of slightly different frequencies are played simultaneously. The closer the two sounds are in frequency, the lower the frequency of the beats. It can be shown that the beat frequency F is equal to the difference in frequencies of the two sounds. That is, F equals F1 minus F2. Or F equals F2 minus F1. Beats are formed by the superposition of two sound waves with slightly different frequencies and similar amplitude. The interactive model shows the displacement time graphs for two such waves in blue and green. The resultant wave formed by superposition is shown in red. Set the blue frequency to 1.2 Hz and the green to 1 Hz. Freeze the graph after 6 seconds. When the amplitude of the resultant wave is maximum, what do you observe about the green and blue waves? Answer: they are in phase. When the amplitude of the resultant wave is 0, what do you observe about the green and blue waves? Answer: they are in antiphase. Use the time scale to measure the beat period of the red resultant wave. From this, calculate the beat frequency. Answer: the beat period is 5 seconds and the beat frequency is 1 over 5, which equals 0.2 Hz. Press play and observe the rotating phasors. One phasor rotates faster than the other, indicating that the phase difference between the two sounds is varying. Beats occur because the phase difference between two sounds varies with time. At the moment when they are in phase, constructive interference occurs, and at the moment when they are out of phase, destructive interference occurs. Set the frequency of the green wave to 0.85 Hz and keep the blue wave's frequency at 1.2 Hz. Use the time scale to measure the beat period and frequency. Answer: the beat period is around 3 seconds and the beat frequency is 0.33 Hz. The beat frequency is greater now because the difference in frequency is larger. Display the beat frequency and period readings and investigate the formation of beats for other pairs of sounds at different frequencies. Click Derivation to view the derivation of beat frequency by the principle of superposition. A violinist struck a tuning fork of frequency 512 Hz and plucked the strings simultaneously. If 5 beats were heard in every second, what are the possible frequencies of the violin? Click Solution. Summary: when two notes which are slightly different in frequency are sounded simultaneously, the resultant intensity will vary from maximum to minimum periodically. This phenomenon is known as beats. Beats occur because the phase difference between two sounds varies with time. At the moment when they are in phase, constructive interference occurs, and at the moment when they are out of phase, destructive interference occurs. The beat frequency equals to the difference between the frequencies of the two sounds F equals F1 minus F2.